So now we wish to consider arrangements with repeated objects. So in the previous video we looked at arranging a group of people, so each person is different. We looked at creating a number. We're using 5 different digits, so each option was different. We looked at arranging the letters of the word grouped, where every letter in that word is different. If instead I asked you to arrange the letters of the word banana, that's going to throw up new problems because there's more than one A and more than one N in the word banana. So that means that there are going to be, using the techniques we have used already, there's going to be some repeated options because the two A's, whether you put them that way around or that way around, are still going to form the same result. So we want to think about arrangements in which we have repeated objects. Okay, so let's start simple. So we have 3 different shapes. In how many ways can the following 3 shapes be arranged? So we've looked at a problem like this with people on the previous video. So there are 6 different ways that we can arrange those 3 objects. Okay, but if 2 of the 3 shapes are in fact identical, there are not going to be 6 different arrangements because we've ended up with some repeats. So those 3 can be considered repeat objects, and there are in fact only 3 different arrangements if we have 3 objects in which 2 are identical. Alright, what about if we have 4 objects? So again, we've already looked at in the previous video that there are 24 different ways to arrange 4 objects, 4 factorial. But what if 2 of the objects are the same? So now we don't have 24 different arrangements. We've got some repeats. In fact, we've got 12 repeats, so there are only 12 different arrangements. So if we have 4 objects in which 2 are the same, there are only 12 arrangements rather than 24. What about with the 4 objects if we had 3 of the objects the same? Obviously there's going to be even fewer arrangements. So we've got lots and lots of repeats here, and we find that there are actually only 4 unique arrangements. So summarising those numbers that we've just worked out, so if we've got 3 objects, if none of them are identical, there's 6 different arrangements, 3 factorial. If 2 of them are identical, so we've got 2 identical objects and 1 not identical, there are only 3 different arrangements. If we have 4 objects with 4 different objects, so none of them identical, we know that there are 4 factorial or 24 different arrangements. But if there are 2 identical objects within those 4, we only have 12 different arrangements. And if there are 3 identical objects within those 4, we only have 4 different arrangements. We could extend that out. I'll give you the numbers for 5. If we have 5 objects, we know that we can arrange those objects in 5 factorial different ways, 120. But if 2 of those objects are identical, the number of arrangements reduces to only 60. We've ended up with half the arrangements we had with no identical objects. And if 3 of those 5 objects are identical, we'll end up with only 20 different arrangements. Okay, so it's fairly clear here, I'll just grab the pen. It's fairly clear here that what we're doing is dividing by 2. We're seeing a pretty consistent pattern here. And that is in fact the case. We haven't got as big a sample looking at when we've got 3 identical objects, but we can see that here, so there we've divided by 2. If we have 4 objects, 3 of them identical, that's been divided by 6. And if we have 5 objects, 3 of them identical, that's also been divided by 6. Now, 2 is actually 2 factorial, and 6 is actually 3 factorial. So what we find is if we have n objects, we know we can arrange them in n factorial different ways. If 2 of those objects are identical, we need to divide by 2 factorial. If 3 of those objects are identical, we need to divide by 3 factorial. If we would have a group of objects in which 10 of them were identical, we would need to divide by 10 factorial. That would be how many extra arrangements we've ended up with if there were no identical objects. Okay, so arrangements with repeated objects. The number of ways to arrange n objects in which there are a identical objects is n factorial over a factorial. We can extend that out to the number of ways in which to arrange n objects in which there are a identical objects and b identical objects and potentially other collections of identical objects. It's just going to divide by each of those repeated objects. So we can divide by a factorial and also by b factorial. So let's have a look at some examples. Okay, so in how many different ways can the letters of the following words be arranged? So apple. So apple, we've got 5 different letters, so there's 5 factorial arrangements, except that will be too many arrangements because of the double P. And in fact, it is 2 factorial too many, so we need to divide by 2 factorial. So we're going to have 120 over 2, so 60 different arrangements of the letters of the word apple. If we have the word pineapple, so pineapple has 9 different letters, so 9 factorial arrangements, except we've also got to factor in the repeats. So there are 3 P's, so we need to divide by 3 factorial, and there are 2 E's, so we're also going to need to divide by 2 factorial. So we're going to do 9 factorial, I'm just working this out, divided by 3 factorial multiplied by 2 factorial, which is just 2. And so we're going to get 30,240 different arrangements. That's opposed to 9 factorial arrangements with 362,880, but accounting for the fact that we've got repeated objects, so some of those arrangements will be repetitions of each other, we're only actually going to have 30,240 different arrangements. Okay, example 2. Find the number of different ways that the letters of the word success can be arranged without restriction. Okay, so with no restriction, we've got 7 different letters, but we've got 2 C's, and we've also got 3 S's. So we're going to need 7 factorial divided by 2 times 6, so that is 420 arrangements of success. No restrictions, but accounting for the fact we've got repeated letters. So then what about if it starts and ends with S? So you still work out the number of different ways that it could happen without any restriction and without accounting for the repeated letters, and then you still divide for the repeated letters in the same way that we have been doing. So starting and ending with an S, we know we're going to have S, then we're going to have 5 letters in the middle, and we're going to have another S. So there's one option, there's not. There's 3 options for the first S, there's 2 options for the last S, and then we've got 5 letters that can be arranged in any order in the middle. So the number of ways that we can start and end with an S is going to be 3 times 2 times 5 factorial, but then we also need to divide by 2 factorial times 3 factorial to account for the repeated letters. Okay, so we're going to have 720 over, that's just 2 times 6, so 12, which means we have just 60 arrangements that start and end with an S. So in summary, the number of ways to arrange n objects in which there are a identical objects and b identical objects and perhaps other combinations of identical objects is going to be n factorial divided by a factorial times b factorial times whatever other repetitions we have. Restrictions should be considered as usual before also applying or factoring in any repetition.